So we can do some modeling with arithmetic sequences, some real-world situations. So we're going to write a recursive rule and an explicit rule for the sequence that models the situation, and then use the rule to answer the questions. So there are 19 seats in the row nearest the edge of a theater. Each row after the first one has 2 more seats than the row before it. How many seats are in the 13th row? So what it's doing here is it's giving you a position relative to the ones before it. So that's kind of implying a recursive relationship. So we're going to let n represent the row number. So we're going to start with 1 for the first row. There's no row 0. So the verbal description gives you a recursive rule. Again, the row has a relationship compared to the seats of the row before it. So they're saying f of 1 is 19. Row 1 has 19 seats. So then the next row, row 2, would have whatever the previous row has plus 2. Each row has 2 more seats than the row before it. So for n is greater than or equal to 2. Since the initial term is 19 and the common difference is 2, we can write that in explicit form. F of n is equal to 19 plus 2 times n minus 1, since we're starting at row 1, for n is greater than or equal to 1. So to find the number of seats in the 13th row, we use the explicit rule. If you're looking for just one particular value, that's when you'll want to use the explicit rule. So f of 13 would be 19 plus 2 times 13 minus 1, which equals 43, which means there are 43 seats in the 13th row. If we wanted to know all of the rows, we could use that recursive rule. It's fairly simple to use that one, but if we're looking for just one specific spot, that's when we want to use the explicit. Student with a part-time job borrowed money from her parents to purchase a bicycle. The graph shows the amount the student owes her parents as she makes her weekly payments, and the amount owed is shown only for the first 5 weeks. So in how many weeks after purchasing the bicycle will the loan be paid off? We're going to let n represent the number of weeks since the loan was made, starting with 0 for the time at which the loan was made. The sequence of amounts owed is arithmetic because the weekly payments are equal. She pays the same amount each week. So determine the amount of weekly payment. Let f of n represent the amount owed at week n. So we can see from the graph, we're essentially looking for the slope. F of 0 is 800, and f of 2 is 700. So the general explicit rule says that f of n is equal to a plus d times n. So we're going to plug in some values. F of 2 should be equal to f of 0 plus 2 times d, since we went 2 days in advance. So f of 2 is 700, which is equal to 800 plus 2d. We got negative 100 when we subtract that 800. So d is equal to negative 50. So that means she's paying $50 each week, and we're decreasing because she's paying it off. So the explicit rule, f of n is equal to the original payment, or the original amount, 800, plus negative 50, because the value is decreasing, times n. So the recursive rule for the sequence would be f of 0 equals 800. You say what your original point is equal to f of n is equal to f of n minus 1 plus that common difference of negative 50 for n is greater than or equal to 1. So determine when the loan will be paid off. You want to find the value of n for which f of n is equal to 0. We want to have our loan value be equal to 0. So we use that explicit rule. We want our function equal to 0. So we said 800 plus negative 50, n is equal to 0. So now we'll have to subtract that 800 from both sides, divide by negative 50 to find n equals 16. So that means her loan will be paid off in 16 weeks. The starting salary for a summer camp counselor is $395 per week. In each of the subsequent weeks, the salary increases by $45 to encourage experienced counselors to work for the entire summer. If the salary is $710 for the last week of camp, how many weeks does the camp run? So starting salary is $395. Summer starts at week 1. So our function for week 1 is equal to $395. So the common difference is going to be 45. That price, how much they get paid, is increasing by $45. So it's going up. So if we want to think about our explicit rule would be f of n is equal to our starting value, $395, plus our difference. Since we're starting at week 1, it will be n minus 1. N is, starting at 1. N is in between sometime t. We're not sure because that's what we're trying to find. So then the recursive rule, we say what their original point is. And so we'd say f of n is equal to f of n minus 1 plus that difference of 45. And then we'd say values for n in between 2 and t. So we're trying to find out what t is, how much time. So the other thing we know is that at the last week of camp, the value is 710. So what we're going to do is we're going to take that explicit function here, and we're going to plug in 710 for our final value. So 710 will be equal to 395 plus 45 times the n minus 1. So subtract the 395, and then we'll divide by 45 to get 7 is equal to n minus 1. So add the 1, n is 8. So that means there are 8 weeks to the summer. The graph shows the length in inches of a row of grocery carts when various numbers of carts are nested together. What's the length of row 25 of nested carts? So based off of the points here, you can see our original point is at 138. So we have one cart, it's going to have 38, its length will be 38 inches. So we need to find out what the common difference is. So I just picked another point at 5 to be 86. So subtracting those values, essentially you're finding the slope of that line since it's arithmetic. 85 minus 38 over 5 minus 1, that common difference then is going to be 12. Now, if we think about our explicit function, f of n will be equal to our original value 38 plus our difference times n minus 1, since our starting position is at 1. And then the recursive, we'd say f of 1 is equal to 38, and f of n is equal to f of n minus 1 plus the difference of 12. So we want to see what's the length of the row of 25 nested carts. So that means we input the number of carts. So we're plugging in 25 for n. So plugging all this in, you should end up with 326 inches, which is 27 feet and 2 inches for the length of 25 carts. That's pretty long. So is it easier to use an explicit rule or a recursive rule to find the 10th term in an arithmetic sequence? It's easier to use explicit. We want to use the explicit when we're looking for one term. And then we want to use the recursive if we're wanting all terms, since they depend on the one before them. Last couple things here. So what do you know about the terms in an arithmetic sequence with a common difference of 0? Well, if we think about it, f of n would be equal to whatever the starting value is plus 0 times n. Well, 0 times anything would just be 0. So f of n would be equal to a all the time, so they're all the same number. They'd all be the same number. So describe the difference between a graph of an arithmetic sequence with a positive common difference and the graph of an arithmetic sequence with a negative common difference. Well, positive common difference will be an increasing, and a negative common difference would be decreasing. So is the rule f of n is equal to negative 2 plus 5n for n greater than or equal to 0 describe an arithmetic sequence? Yes, it does. They all have a difference of 5. A common difference of 5, and it's an explicit sequence because it's specific for one value and it's not depending on the other.